Okay, so for these two examples, we're asked to solve for x, and it says include a check for your solution. I'll probably do that with my calculator. Um, Both of these look like they would be significantly simplified with the application of fraction busters. So let's take a look at this first one. Um, I caution you that these denominators are binomials, right? There's two different terms. There's an x and a negative 3, there's an x and a positive 2. And because I see these as for the binomials that they are, right, it's probably a good idea for me to put parentheses around these like this, right? So what I'm seeing here is that I need to get rid of those fractions, and I believe that if I multiplied both sides by an x plus 2 and an x minus 3. So again, over here, I'm going to multiply by an x plus 2 and an x minus 3. So with these parentheses in place, right, it's real clear to see that, oh, there are common factors. The factors are complicated, right? They're binomials, but they're still common factors. And over on the left-hand side, I can see that the x to the negative 3 over x to the negative 3, right? They form the number 1. So that's gone, right? X over 3 is gone. It's just the number 1. And over on the other side, I can see that there's this y plus 2 over the y plus 2. Or I'm sorry, x plus 2 over x plus 2. So those are gone as well, right? Gone. So if I look at it, let's look at what my numerators become. On the left-hand side, I've got an x plus 2 that I'm multiplying by 2x. And over on the other side, there is a 2x plus 1 that's being multiplied by x plus 2. Okay. Okay, so I need to do some multiplication here. I need to expand this. I need to multiply this 2x by both the 2 and the x. So when I do that on that side, this is going to become 2x squared plus 4x. On the other side, I can see that I have a binomial times a binomial, and it's always my recommendation that when you see this, you should consider using a generic area model. So let me make a 2 by 2 model. In this 2 by 2 model, I can see that I've got a 2x that's being increased by 1, and then along the bottom I've got an x that's being increased by 2. So I'm trying to find this product. Oh, I've made a mistake. I can see it now too. The x plus 2 was part of the giant 1 that was eliminated. This is going to be an x minus 3. So this is what remains. I have to multiply the x minus 3 times the 2x plus 1. And that significantly changes this because this is going to become an x and then negative 3 right there. So to find the area, to find the product of this binomial times a binomial, I need to find the area represented by each of those 4 regions. And to find areas, we multiply length times width. So in the bottom left corner, when I multiply 2x times x, I get 2x to the second power. 2x to the second power. Above that, I'm multiplying 1 times x. 1 times x is just x. In the top, off on the right, when I multiply x times negative 3, no, when I multiply 1 times negative 3, I get negative 3, right? 1 times negative 3 is 3. And then finally, in the lower right box, I have a negative 3 that I'm multiplying by 2x, which is going to give me negative 6 times x. So now that I know the area of all those pieces, to get the total area, I just have to add these pieces together. I'm going to add them up. 2 of them when I combine, right, because they're like terms, I can combine those into one thing. But the rest, I'm just adding them all together. So here's what I get when I add those. I will get a 2x squared. And then when I add the x and the negative 6 times x, that's going to become a negative 5x. And then when I add the negative 3 in there, right, this is what I get. Okay, so at this point, here's my equation. And it's a wonderful day because both of these have a 2x squared, which I'm going to subtract from both sides. The equation will become 4x equals negative 5x minus 3. If I add 5x to both sides, I get 9x is negative 3. Divide both sides by 9, I get x is negative 3/9, which reduces to negative 1/3. So x is negative 1/3. Now, checking that would be an important thing, right? I'm supposed to produce a check. So let me turn on the calculator here, and I'm going to turn it on and clear it. And I'm just going to enter negative 1 divided by 3, and I'll put that on the stack, right? So I've got my 1/3 there. So on my left-hand side, I've got a 2 times that. So I'm going to go 2 times, go grab that number, enter. And then I have to divide that by, I'm going to do open parentheses, and I'm going to go get the x, go get that number, and I'm going to subtract 3 from that, close parentheses, and press enter. So when I do that, this side becomes 0.2, right? When I plug in the value of 1/3, right, x is negative 1/3 rather, I get 0.2. So now let's do the same thing for the other side. So I'm going to go open parentheses, 2 times, go get x, there it is, I got it, and then I'm going to add plus 1, close parentheses, divide, open parentheses, go get that x, and add 2, close parentheses, enter. Aha! So you can see that on the right-hand side also, when I plugged in negative 1/3, I got 0.2. So this is a solution, right? X is the solution because when I plug negative 1/3 in to both sides, it makes both sides become the same. In other words, it makes both sides equal to each other. So that is our solution, and we've checked it. Let's look at B. Okay. So again, fraction busters would be very convenient here. I think I need to multiply everything by 20, right? This number 4 contains 2 factors of 2, 2 times 2. So if I multiply by 4, right, which is 2 times 2, it's going to take care of this 2 at the same time. So I don't need an additional factor of 2. All I need to do is multiply by just 4 times 5, which is 20. So let's go ahead and begin. So every single term on both sides is going to be multiplied by the number 20, right? This is going to get a factor of 20, this is going to get a factor of 20, this is going to get a factor of 20, and this is going to get a factor of 20. All 4 of them. Well, 2/5 times 20, 20 divided by 5 is 4. That becomes the number 8. Grab your calculator if that doesn't seem like 8 to you. Type 2 divided by 5 times 20 and verify, yeah, that's 8. The next one, 20 divided by 4 is 5. This is going to become plus 5x. So both of the terms on the left-hand side were hit with a factor of 20. And then that's going to equal 5 times 20 is 100 minus, and then x divided by 2, 20 divided by 2 is 10. This is going to be minus 10x. Let's add 10x to both sides. So I've got 8 plus 15x is 100. If I take away 8 from both sides, I get 15x is 92. Is that divisible? 92 divided by 15. That's not. But I'm going to kick it into a fraction. So I do get x is 92/15. Okay. I'm going to kick that into, I'm going to simplify that as a fraction. Math, enter. It reduces to, it does not reduce. It's 92/15. All right, so we've got 92/15 as our answer for the second one, and it doesn't reduce. But now let's check it. Like, what do the left and right hand sides become if x is 92/15? Let's go back to our calculator. Clear it again. I'm going to do the same thing. I'm just going to go 92 divided by 15. There is my answer for x expressed as a decimal. If I want, I could actually hit math, frac, and I could kick it into a fraction as well. So I'm going to go ahead and take 2 divided by 5 plus x, right, x divided by 4. And when I do that, I get this number. I guess I could remember it. It's 1.9 and a bunch of 3's. Let's see if the other side becomes the same thing. Oh, please, oh, please. So I've got 5 minus, go get x. There it is. I got the x. And divide the x by the number 2. And when I do that, I get, oh, that's interesting. I get 92/15. Let me go grab this value and ask it to display itself as a fraction. So I'm going to hit math, enter. Aha! So here's the thing. That's bizarre. Oh, so when I plug 92/15 into both sides become 29/15. So this side becomes 29/15. This side becomes 29/15. In other words, that value is exactly the value that would make these equal. So this is my solution. It makes both sides the same as 29/15.